I don't know why it goes back to the default device of nothing all the time, but that's what we got to deal with. All right, let me rotate this. Hey, everybody, how's it going? Hello and welcome. So we're going to do some studying from these books. Now, I've done some studying of my own already up to this point. So there is hopefully some benefit from that. And then let's see if I can get this oriented. The chat should show up over here. Let's see what's going on with the chat. I don't know why the chat's not showing it. Give me a second to go see if I can fix what's wrong with the chat here. So I'd put up that timer again. We're still just working through a little bit of technical difficulties. But let's see. Soundboard works? Yeah, soundboard works. Great. iPhone. We're not taking any sound from that, thank goodness. All right, I'm checking some of the... the chat should be up over there, but it's not. So I'm going to switch. I'm going to try to grab the chat from one of the other scenes and then come back. Okay. Let's go back to this scene. I'm going to paste in new chat URL. All right, the chat's ready. Cool. Good. All right, now the chat's working. Let's see. All right, we might have a little bit over there. I'm going to zoom in a little bit. Pull this back over towards me a little bit. Okay, cool. So let's pop top, my friends, and we'll go ahead and get started. So the idea here is that you've probably heard about POSIX shell scripting because that's what you have to do for Docker. And it's kind of, in a way, it's both ancient and modern. It is the older way of scripting, but because the way that the Unixes and the environments in which we run code have changed, it's become the newer way of scripting. So what is old is made new again. And there are no books on, sorry, I keep on saying POSIX, it's POSIX. It's POSIX. I don't think that Richard Stallman, who proposed the name of POSIX, or proposed the pronunciation at least, it's supposed to be I'm positive about POSIX. Pauses and positive. Positive about POSIX. I think he was kind of pulling I don't know, because the pronunciation is just so, it should be pronounced differently, but it's pronounced POSIX. Anyway, so POSIX scripting is what we need to be able to do, but it's not what we get to do all the time. Well, it's not what we have good resources for. And so I've got two books here, Linux Command Line, and then I've got Mastering Linux Scripting, and I'm going to be going through them and taking notes, and with the intent to make course material that's based on POSIX scripting. So I am using these to kind of see what's the format, what's the layout, what does it look like. Yeah, I'm streaming both on YouTube and on Twitch for this. So we should have, we have sound now. That's right. So before we get started, let's have a quick word from our not a sponsor, Mr. Mountain Dew. Pop a top, my friends. Oh, there we go. That's a good one. Okay, so let's go ahead and just dive in. We're just going to open the book, and we're going to go through, and I'm going to be making commentary. I'm going to reading some stuff. I'm going to try to be respectful of the author's... No, I'm going to be respectful of the author's copyright. So I'm going to be showing some passages and whatnot on here, but, this is go buy the book if you want the book, right? That's going to be the idea. Is that this is not going to be a replacement for reading these books, or maybe it will, but not in that way. So I'm going through, Actually, I need to reposition this camera just a little bit here. Hold on 1 second. All right, we're gonna. Oh, hold on. I need this to come around. There we go. So that come around back this way, and then have this over this way. Oops. And then it looks like I hit exposure lock, and the exposure is not quite right. So let me try to fix that. Let's see, focus, zoom, ISO. Let's get the ISO, let's get a little brighter. There we go, a little noisier, but whatever. And then, now that should come together pretty soon here. Okay, cool. So, yeah, now I can actually get, it's not in the way of my hands. So I've already taken a preview at both of these books, and I have to say that I think the Linux command line is going to be the better book for learning scripting in general. It's not because it's thicker. It's quite a bit thicker between the two books. Where'd the other one go? It's right over here. So this one, thickness there versus thickness here. Got to get a feel for it. But it seems like the writing style is a little bit better, and the kind of things that it covers seem a little better. But we're just going to go through, and I'm going to go fairly quickly because I'm already familiar with this stuff and I'm studying this for myself to try to learn how do I create better material. But anyway, we will go ahead and get started, and I'm going to tell the chat not to hide things. Give me 1 second to do that. Where are hide messages after 180 seconds? No, we're not going to hide messages. We're going to leave the messages up. All right, and then yeah, so here we are. So let's just go over kind of the overview of the book, and I'm going to possibly make some comments here, what the different chapters are, what is this covering, what are we going to be learning from this. So let me just kind of see. This one's got so many chapters in it. I actually think it's quite good. There is a lot to learn. So introductory material, what is the shell? I think that's important. I think it's important to be able to distinguish between the shell, the terminal, and a command. Those are the three things that you're interacting with on the command line. And if you don't know the difference between the terminal, the shell, and the command, it leads to a lot of confusion, understandably so. We're going to be learning about navigation. This is just basic stuff. How do you get through files and folders? I think everybody needs to know this. Let's see. Whoop. I went too far. Let me see here. Sorry, I lost my place. I fat-fingered it too early. And this is going to be, we might have 10 sessions of this. I'm not sure how long this is going to go. So we've got navigation, we've got exploring the system, manipulating files and directories. So all of that is kind of all the early parts here. Working with commands, like I said, it's important to know the difference. Redirection. So output can go in multiple different places. There's what's called standard out, which is what prints to the screen. There's standard error, which also generally prints to the screen, but you can have it redirect to logs and stuff. Seeing the world as the shell sees it, that's pretty cool. So that talks about expansion. Keyboard tricks. I'm going to be interested to learn this because I know that there's a few keyboard tricks. It depends on what shell you're using. This doesn't. One thing I'm disappointed that this doesn't do is it doesn't distinguish between scripting shells and interactive shells. Because in scripting shells, keyboard tricks are not something that you care about. But in interactive shells, keyboard tricks are something that you care about. Yeah, messages are for all to see. Okay, permissions. This is something that more has to do with the operating system than it has to do with the shell, but POSIX operating systems have certain permissions. That one, when we get to that, I don't think we're going to spend a whole lot of time on it because most of that's not relevant to the way that we write programs and deploy programs today. It is relevant to being secure on our own personal workstations, but it's not really relevant to deploying in Docker, for example. And it is relevant in shared hosting scenarios, but shared hosting scenarios are vanishingly small. It's literally, shared static hosting is all that is nowadays. Processes, okay, we'll learn about that. The environment, that's good. I like that this one has a gentle introduction to VI. VI is Vim. There's Vim, and then VI or Vi. I'm not sure how people like to say it. I call it VI. I should probably learn what the intended pronunciation is at least. But that is a very, very simple editor. People make it way too complicated because it's very powerful. So you can do anything with it, but you don't need to be able to do everything with it in order to do the basics. And so I like that this includes the gentle introduction. Customizing the prompt, this is pure vanity. It's like vanity plates on your car. Totally not functional, doesn't matter. Interesting section to include. Part 3, package management. That has nothing to do with the shell, but I guess it's good to know that such things exist. That's just common stuff you're going to be dealing with when you're working from the command line. You're going to be installing packages and stuff. Let's see, storage media. This is kind of interesting. I mean, I guess this book is focused on Linux, but this is not relevant to shell scripting. We'll probably gloss over that. Networking, I think, is relevant because a lot of what you're going to be doing as a web developer is dealing with just really basic web stuff. So HTTP, DNS, etc. So I think having a chapter on networking, that sounds great to me. Let's see, searching for files. Didn't we already cover that? Some of this, I'll make comments on that once we get there. Yeah, some of this stuff we're going to just breeze through. Regular expressions. It's good that it has a section on regular expressions because that's relevant to programming. It's relevant to scripting. It's just relevant to so many things. If you are in anywhere in that space of from DevOps to, it's really relevant stuff. And actually, I'm going to pull this over here towards me and push this over there. There we go. Is that too dark? My custom prompt isn't vanity. You are mistaken, good sir. You are mistaken. All right, and it looks like I accidentally still have that automatic refresh turned on. So let me double check that setting so that we're not losing our comments here. And I'm also going to increase the opacity quite a bit up to 70% for this one. Okay, let's try that again. Dude. It's not loading. It's not reloading. Hold on. I'm going to have to force it to reload here. Oh, that did not force it to reload. That's crazy. Is it loaded somewhere else? I think I might have it loaded somewhere else. Let's see here. Give me a second on that. 1, 2, 3, 4, 5. And there we go. All right, chat messages are back. Archiving and backup, regular expressions. This is going to be interesting because regular expressions is one of those things like Vim, where if you learn the basics, you only got to learn 10 things and you're done. But if you want to learn everything, you can learn hundreds of things and not be done. And I don't like that kind of stuff. All right, Python shell is not POSIX shell. But we can talk about that too, because there's an element there that's similar. When we talk about interactive Python, using the Python prompt is different than writing a Python program. And I have some of the same feelings about the shell. Text processing, this is going to be good because a lot of what we want to do on the shell, especially as developers, is we want to be able to find things inside of text files really easily, or we want to be able to refactor some code and rename a class across 50 files very quickly. Let's see, formatting and output. Some of this stuff is completely new to me. I'm not familiar at all with NL or PR or Graph, so I'm going to be learning some stuff about that. Printing. Do people even have a printer anymore? Maybe that's not the kind of printing they're talking about. No, they are literally talking about sending jobs to printers. Okay, so we're probably going to, when we get there, that'll be a little while yet. We'll just gloss over that. Compiling programs. Now, this is interesting because the POSIX standards do define a lot about C programming. And so we'll be learning a little bit about that, which will be good. It's good to understand kind of how C works because everything else is kind of using C as a frame of reference. Let's see. Shell scripts, writing your first script. That should have gone in chapter 1. Starting a project. Okay. So it does kind of, I guess it's taking the approach that the first 23 chapters are more about the interactive shell, and then the next few chapters are going to be about scripting. Okay, here docs, minimal document, adding a little data. Okay, that's good. It's got a project section. Top-down design. I don't know what it means by that, but that'll be interesting. Flow control. Okay, so here we get into the programming aspect of scripting. So there's the shell, there's the terminal, there's scripting, there's commands that we create that are built in, reading keyboard input, flow control, troubleshooting. Let's see, this one was looping. Over here we're talking about branching, positional parameters. This is really important. This is what things can you pass to a command. So if you've used commands before, you can pass a file name to it, or maybe multiple file names. So that's good. And it talks about for. It's interesting that for loops come all the way here in chapter 33 when the first flow control is introduced on 27. All right, strings and numbers, that'll be interesting. This is probably a lot of stuff that's highly bash specific, and I'm not going to recommend that you really dig into. And then arrays. Arrays are bash specific. I'm going to gloss right over those because I'm concerned with POSIX scripting. I'm not concerned with scripting in general. And then exotica. Group commands. Okay, cool. So that's the overview of this book, and this is the book. Oh, did we lose? It looks like we lost the video here. Let me see what happened. I didn't realize that. Let's see if I can get the video back. Can we get the video back? What in the world happened? I'm going to unplug and replug. Come on. That's not something we want to have happen. We don't be losing our video. All right, let's see. Doot doot. Doot doot. All right, and this is back again. So I'm not going to go back over that, but hopefully you heard it, and that'll be good enough for now. Let me bring back up the exposure on this because that's a little bit dark. Give me just a second to do that. Again, I apologize for these little technical difficulties. All right, there we go. And then we'll get that back. Okay, and I want to go over the table of contents of this other book as well. Yeah, I just fixed the book camera. Thanks for pointing that out. So you should be seeing it now again. All right, I'm going to go over just the table of contents in this one as well. All right, the what and why of scripting with Bash. That's chapter 1, creating interactive scripts. So that's interesting. Let's see, does he talk about flow control or anything here? So editors. I do kind of like that he goes into editors a little earlier on, because I think that's, if you don't have an editor, then what do, right? You can't write a script. Well, you can't write a script without an editor, but you can use the shell without an editor. So I guess that's why the other one does that first. Let's see. So it's got chapter 3 is conditions. Chapter 4 is creating code snippets. Chapter 5 is alternative syntax. Chapter 6 is iterating with loops. It does have, it highlights IFS here, which is good. IFS is something that unfortunately you will have to, well, I shouldn't say unfortunately, it's not that complicated. It's the internal field separator. It's whether spaces, tabs, and new lines, carriage returns, and carriage return new lines. It's how those are treated. But that'll come later. All right, creating building blocks with functions, introducing the stream editor. So that's talking about modifying text in place, automating Apache virtual host. So this guy comes a little bit more from a sysadmin perspective. Awk is something the other book doesn't cover at all, and something that Awk is it's a scripting language, kind of like Python, but it's more C style. So it's a C style scripting language that is often used by sysadmins in shells. I don't think it's something that as web developers needs to continue to be propagated. All right, good. He's also talking about regular expressions and grep. And he does have these nice practical projects that come from the perspective of a sysadmin, which I think is good. A lot of people want to learn shell scripting because they are a sysadmin. We're not taking that approach. We're taking the web developer approach. So this book I don't think is as good. Using Python as a bash scripting alternative. Again, that's more of a sysadmin thing, because if you're a web developer, you're going to use whatever language you use as your alternative when you need more control than what you get out of a shell script. And other books you may enjoy. Okay. So I don't know exactly how we're going to bridge between the two of these, but I'm going to start with this one, and we're going to dive into chapter 1, and then I've got physical notes that I'm going to be taking, or I may bring them up on screen. We'll see. But I've got some physical notes I want to take. And yeah, feel free to ask questions at any time. Tell me to slow down. Tell me to go back. Say, hey, could you expand on that more? All of that is really good. Let's, be a good chat. Let's have a fun time together. All right. So I'm gonna kind of halvesy this, where I read a little bit to myself and then I point some stuff out. And for some of it, I'll let you read along as well. Again, I'm going to be respectful of the author's copyright. I'm not going to try to reproduce the whole book here, but just kind of use this as a prompt for us to talk about different parts of scripting. Okay, so introduction here. Linus Torvalds, he's the guy that created Linux. Okay. Richard Stallman is the guy that created GNU. GNU is not Unix. Linux and Unix are kind of a similar family, but a different heritage. Linux was written from scratch. Unix has a whole bunch of kind of ancestry. So, for example, Mac is actually an ancestor of Unix, and or not an ancestor. Sorry, Unix is one of the ancestors of Mac, and then there's BSD, the Berkeley Standard Distribution of Unix, FreeBSD, some of these other things. So this comes out of the Unix history, and the reason that I'm going to be talking about POSIX is because POSIX is kind of it's a unified standard that you can expect on any Unix, whether it's Mac, whether it's the Nintendo Switch, whether it's the PlayStation 4. You can expect certain things to behave the same way, assuming that you can actually get access to them, which, in the case of game systems, they don't like it when you do that. But if you do, they are Unix systems. Hey everybody, how's it going? Okay, why to use the command line? For me, the reason to use the command line is mostly about efficiency. They say, there's the phrase, a picture is worth 1,000 words, but I would also say that a picture costs 1,000 words. It's much easier to give somebody something that they can copy and paste than to try to explain how to do something. And as web devs and sysadmins and DevOps and all of those roles, what we want to do is we want to be able to automate. We want people to be able to experience the same success that we have experienced without having all of the same knowledge or taking all of the same time that we have taken. So that's why command line and scripting is important to me. It's a faster method of communicating important information. Let's see what's in this book. This book is for Windows users. All right, I'm mostly gonna skip over this section. Let's see. Let's just, again, summary is learning the shell, configuring the environment, common tasks and tools, writing scripts. That's kind of how he wants to lay it out. He talks about Linux. I'm not really worried about that. You've got WSL if you're on Windows. By the way, webinstall.dev/WSL if you need it. I think somebody told me that Microsoft in the latest release, they totally revamped the process for the Windows subsystem for Linux, WSL, and it's super easy now, and you don't need extra tools to do it. But if you're on one of the older versions of Windows and you haven't updated yet, webinstall.dev/WSL. And then otherwise, what I recommend and I think that this might even be in the description of the video. I think I have this as a standard thing, is to have to use DigitalOcean. I don't think that there's a lot of need to learn Linux from the perspective of installing it on a desktop computer. If you want to do it, if philosophically that's what you're into, more power to you. I've got a buddy, he's got the full setup with multiple monitors, he's got a system dock, his system is configured awesomely. He's using Pop! OS, and it looks like everything is just working for him, and it's amazing. But for me, I prefer Mac. It took me a while to get there. I was on Linux for a long time as a desktop user. My first Mac, I exclusively ran Linux on it. I don't think I even booted it up into the Mac operating system. I literally I bought the Mac so that I'd have a nice trackpad, because I think I'd experienced the trackpad and realized that they were just really awesome. And I just put Linux on it. And I ran that for a couple years until people who had Macs kept on asking me, why are you running Linux on your Mac? Don't you know you've got all the same tools in the Mac operating system? And eventually I got converted, and now I'm stuck. So take that for what it's worth. But here's a section I want to actually read. It's more of a philosophy thing than a skills thing, but why I don't call it GNU Linux. Okay, in some quarters it's politically correct to call the Linux operating system the GNU Linux operating system. So Linux is a kernel, and GNU is a bunch of tools that run on top of the kernel. So in the same way that I was differentiating between terminal, shell, and commands, there's the Linux kernel, and then GNU applications like GNOME Desktop and stuff like that. The problem with Linux is that there is a completely correct way to name it because it was written by many different people. Oh, there is no completely correct way to name it. It's written by many different people. Linux is the name of the operating system's kernel, nothing more. The kernel is very important, blah, blah, blah. Entered Rich Stallman. I want to see, what is his argument here? Linux refers to the kernel and all the stuff. The entire Linux ecosystem, not just the GNU components. And that's fair too, because it's not GNU Linux. It's because there's a lot more than just GNU software that runs on Linux. For example, KDE is not GNU, which that's all in the noise. That's not stuff you really need to be worried about. But I was just kind of curious to see what he says here. All right, cool. So that was interesting. And then he says, what's new in this book? All right, so Bash added new features. I don't care about any of those. I care about POSIX scripting for Docker, for web development, that kind of thing. I don't really care. And I care about interactive. I care about the interactive shell. And Bash is not a shell you're going to use as your interactive shell. If you're old school, you're going to use ZSH. That's what's default on Mac now. If you want to have the stuff that's just the best tools, the best technology, Fish. So webinstall.dev/fish. That'll bring you to Fish. Fish is, it's spelled like fish, like stinky fish, like fish you eat. All right, what's the shell? All right, when we speak of the command line, we are really referring to the shell. This is important. Shell is a program that takes keyboard commands and passes them to the operating system to carry out. So, and then he makes the distinction of terminal emulators. And I think this is the first thing that you need to know. The terminal, I would say the terminal is kind of like the web browser. It's all of the feature set that is provided for the web app to display its stuff. So the terminal is where the shell gets to do all of its stuff. And your web app is connected to the internet through the web browser, which provides the interfaces to be able to do that. Likewise, your shell, it has the interfaces through your operating system to be able to run commands and stuff like that. So it's not the terminal that runs the commands. The terminal is, let me see if we can go back here for a second. Let's see. Yeah, go back here. Okay. So let me just bring this over. Whoops. And then we're going to turn that one off for a second on this one. Okay. So here in my Omnibar, this is kind of like my prompt, which we'll get to this in a second. But this is where you get your autocomplete, your history of all the things you've done, all of that. That's up here. Your terminal has tabs just like your browser has tabs. And then what is running inside of your terminal is either your shell or a command that your shell is running. So I think that's good to know. Oh no! This it restarted the. I didn't want to take these away. Oh well. Oh well. Okay. So that's important. So there's a difference between the terminal, the shell, and then the commands. All right. Making your first keystrokes. I think this is great. I think the way that they're approaching this is great. When you open up a terminal, and maybe I should actually restore on here. Let's see if I can. Can I get... I will actually put here macOS screen capture. No, let's not. Oh no, that's not what I want to do. Ah! Dang it. Go away. It's not what I wanted. Let me try this again. So we have... Wait, where's my old screen capture stuff gone? Display capture is no longer here? Seriously? I guess I got to use the new one. All right, well, might as well. Okay. Let's see. We're going to capture this display over here. Nope, we're going to capture this display over here. All right. And then we're going to capture just part of this. Let's see. Window capture. Nope. Can I do application capture? Sorry about this. The software's been updated and my thing isn't working the way that I want it to. Okay, so we're going to pull this back up. And I don't want this. Hold on, here we go. I'm going to bring up my terminal in just a minute. Let's see if I can get the terminal up here. Is there another one I want to use? We're going to use this one. Okay. So give me just 1 second while I grab that. So application capture. We're going to go to iTerm. Great. Okay. So the first thing that you need to know is if you just type stuff in and hit enter, nothing happens. It's looking for a command. I think that's actually pretty good that the book brings up that as the very first example here. In an interactive shell, you do get to use your mouse. That's true. But I don't want to spend any time on talking about mouse focus because that's not anything that you're going to get with POSIX scripting. Let's see, simple commands. This is something that I thought was actually kind of cool. I didn't realize this before. I think it's cool but not necessarily useful. There's a calendar command. I don't know if I've got any use for that, but just all of the little widgets and stuff that you have in your operating system, there's a command line equivalent for them. And I thought that was pretty interesting to see here. But he's just giving some example of try simple commands. I absolutely agree. When you're exploring scripting, you need to just kind of play around with commands and see what happens. Okay. So console behind the curtain. Oh, this is an important piece of information. Let me bring this back up here. Whoop. Okay. So if we have a terminal emulator, if we have no terminal emulator running, several terminal sessions continue to run behind the graphical desktop. Okay. This is specifically in Linux. So there's multiple layers of emulation here. So you can actually have shells running in virtualized terminals so that you could close the terminal, open the terminal back up, and reattach to it. There's a technical term for console, which again, it's interesting to know for Linux. It doesn't really apply to much else, but you can basically hit function, and then I think it's F3 through 11 or something, and it will change your screen from the graphical interface to your entire screen is just a console. So that's interesting tidbit to know. All right, so chapter 1 was pretty simple and easy. It's just, hey, open up the terminal, open up this thing, type at it. I 100% agree. Just try some stuff out. Just hit open some commands, see what happens, check it out. I'm 100% on board with that. Okay. And then I think there is even a help. And this is from the shell. So bash, fish, ZSH. In the case of fish, the help command actually opens up a web page, which is pretty cool. If I were to go to bash and then type help, then I get a list of commands. And if I were to go into sh, let me do that real quick. Hold on. I'll just use that as my bookmark for a second. So if I go into sh and then I type help, this is a POSIX shell. No matter whether you're on Linux or Mac or WSL on Windows, sh is a POSIX shell. That means that it's compliant. If you learn the commands in the POSIX shell, POSIX commands will work the same on every operating system, assuming that they're implemented according to the POSIX spec. There are some exceptions to that. Most notably, the sed command. SED has a few flags that work differently between Mac and Linux. Almost all of them have work differently. So here, you'll notice that I typed in sh to get to a POSIX shell, and it still tells me I'm in GNU Bash. And that is interesting and somewhat important. When you type sh, it will often execute bash. It could execute another shell called dash or ash or ksh. Any of those shells. Let's see if ksh is on here. Yeah, it is. That one doesn't have a help. Let's see, help. So many of these shells have what's called a POSIX mode, where when you invoke them as sh, then they will behave cross-platform compatible. What's up, Honda Accord? How's it going? Yeah, Tmux. Sorry, I didn't see that earlier. But yeah, Tmux, I use Screen because it's got better compatibility. But a lot of people like Tmux. What that is the ability to have, and I'll actually demonstrate this right now since it was brought up. So you can type Screen. I do it this way. Dash lowercase x rs. So the way I remember this is X marks the spot. R. I'm a pirate. So it's XRS. And the S is for spot. But actually what it stands for is something like X is for allowing multiple sessions at a time. R is for reading a session if it exists. And then capital S is for creating a session if it doesn't exist. Or something like that. And I just name my session awesome all the time. And so if I go into this, then I can open up cal here. And then I can hit Control AD. And I can leave it. And I can go do something else. And then I can come back, and then it's right where I left it. So that's back to the discussion about the virtualization of terminals and consoles. So Screen and Tmux are a way to have something running that I can close this out. So I can even open up a new terminal entirely, and then I can run this command again, and then boom, it brings it back up, and I can detach from it again, and it takes it away. So that's kind of another layer. So there's the terminal emulator, there's the shell, and then there's the commands. And commands include shell and terminal emulator. In fact, the first thing that the terminal is going to run is its initial command, and its initial command is whatever shell you set it to. So me, for iterm2, let's see here. As soon as I get into this, it's settings. Okay, here we go. If I go to, what is it, profiles? Yeah. So you can see here the default command that this is going to run when it opens is fish. And yeah, I could set it to login shell. I could set it to custom shell. I could set it to command. I think that's custom shell. There we go. Anyway. All right, getting back to the book here. So navigation, understanding the file system tree. This is something I tell people when they're learning to program. Oh, the sun came out. Apparently I need to adjust the sensitivity of the screen now. Hold on. All right, there we go. I've got Windows here. So the sun comes out and it changes the sensitivity. Understanding the file system tree is really important. I recommend to people, one of the first programs you should write when you're learning your programming language is to actually try to emulate some of these commands like pwd cd ls. Pwd prints the working directory, so it prints where you are. So for example, I'm in my home directory here. I'll show this. Pwd. So it shows this is what my home directory is. If I move directories, if I go into temp, pwd, it shows where I'm at. And then likewise, well, it says cd. For an interactive, cd is useful for scripts, but it's not really useful for the interactive shell, in my opinion. Not in the same way. It's useful for POSIX scripts, but pushd and popd, and a lot of shells will alias cd as pushd, but pushd and popd allows you to go into something and then pop out of it. So I could go into my projects directory, and then I can go into my CoolAJ6 directory, and then I can go into my blog directory, and then I can pop, pop, and be back. Or I can go in deeper, and I can do some stuff, and then I can pop back out. So I like pushd and popd rather than cd for the interactive shell because it helps you keep track of where you're at. So if you need to go through several things, you can switch back and forth more easily. CD does have an option to do this, kind of, sort of. CD has a memory of one directory, whereas pushd has an infinite memory. Okay, and then list, ls is going to list what you've got. Now, I actually have list aliased to lsd, which is list deluxe is what it's called. So let me go into my projects directory here. Oops. And you can see, so with LSD, what this gives me is to be able to have a folder icon and a movie icon and a lock icon and a JS icon. You know, so it's a PDF icon. So LS gives me LSD, which is my alias for LS. It gives me colors. I get to set up. It comes with better defaults out of the box, but LS will do your listing. Now, this is the difference between an interactive shell and a scripting shell. If I'm doing POSIX scripting, you don't want colors in your POSIX scripts. You don't want to, because what these colors are is their control codes. So it's \x 37m / or something like that. So if I was printing this out to a file, in fact, let me go ahead and do this. Now this LSD is really smart. So I'm just going to go to temp ls.txt. Now if I go open that up, ls.txt, you can see that it doesn't put any of the control characters for the color or any of that stuff. Now when I look at the file, it's color free and it's icon free. But this is a difference between interactive shell and scripting shell. Let's see. Question is, so pop just gets the last item in the list of paths? Yeah, that's correct. That's correct. So pushd puts something onto the stack of paths, and popd takes it off. And you can put multiple things on at once with pushd, and if you do that, then multiple things come off with popd. It's whichever way you decide to do it. All right. So, and I think it's really important. What I would suggest actually is if you open up side by side your terminal and your Finder window. Let me see if I can get this to show as well. So let's see. This one is, let me go ahead and rename this real quick. This is iTerm2. And then I'm going to use, there's video capture device. Is that what it's called now? It used to be called display capture. I think they switched it over to video capture for the whole screen. All right, and this one's going to be called Finder. And we're just going to do window capture. And the window that we're going to capture is, there's a Finder window here. Can I find my Finder window? I don't know what order these things are in. Give me just 1 second. Brave, iTerm, preview, Finder. There we go. Okay, so I think it's nice to have these side by side. And then to be able to look at them, let's see if I can make this bigger. That's already as big as it gets. Can I zoom in? I can't zoom in more, seriously? But I can go into my downloads folder, for example, and then I can list what's in here. That's kind of big. I shouldn't have done my downloads folder because that's huge. It's huge. But I think it's good to kind of see them side by side. Let me create a temporary folder instead. So I'm going to make delete me, and I'm going to go into delete me, and then I'm going to touch foo, and then we're going to go over here, and I'm going to go into delete me, and we're going to see foo, and I'm going to make another folder called hey and I'm going to make can I make a new file? No. Okay. So let me, for this one, I'm going to say window hide sidebar. There we go. We're going to make this bigger so that you can see it better. And then I'm going to go over here. And I just want you to see, this is a connection a lot of people don't make. I know this is really basic, but hey, we're in session 1, right? So if I move this and rename it, you can see now it gets a different icon. So I think that's important stuff to just kind of consider when you're dealing with command line and whatnot. All right. Is popd the same thing as using double dots to go up a directory? No, because you can swap between directories in any order. It doesn't matter what order you're in. And I see the phone has now crashed again, the connection with the phone. So I'm going to unplug and replug that. Maybe this app isn't the best app to use for that. That's okay. Let's see here. And now that's really annoying that I have to redo this over and over again. But here we are. Okay, so let me bring that back up. So it's different because ... takes you up one directory. Take me up one directory again. And in some shells you can do 3 dots or 4 dots or whatever. But with pushd, I can go into temp, then I can go into downloads, then I can go into projects, CoolAJ6 blog, then I can go back into temp, and I'm push. So there is a DIRS command, and it will show you, and this is for interactive shells. It wouldn't make sense to try to use this in a script, but you can see here, these are all the directories that I'm in. So I'm in temp, I can popd and I'll go back to this directory. I can popd again, I'll go back to this directory. I can popd again, I'll go to this directory, again and again and again. So I can get all the way back to home. So it's not just going up or down, it can go sideways. It can go any which way to use popd. Can too many pushds overflow the stack? I can only imagine that it must be so. I don't have a hard answer for you, but I hope so. I hope. That would make me feel better about life in general. Okay, so, whoop. All right, let's take a look here again. So, talking about file tree, current working directory, and then he does the same thing I did. He says, yeah, bring up the viewer side by side so you can see how these things mirror each other. That's awesome. He talks about print working directory, listing the directory, changing the working directory. That's what I did with popd. And here's something that's really important is relative versus absolute. So there are 3 types of ways that you can specify a path. Absolute path begins with a slash. And that I find that I don't use very often except for /temp and /applications on Mac. But that takes you from the very root directory. This is where when the operating system boots up, so on Windows you have the C drive, and the C drive is the root directory. Even on Windows you can ls/ now and it'll work, or dir/, I guess. But these are, and it's not actually showing everything because there's some hidden directories. I can do -A and then I'll get to see a little bit more. some of the hidden directories and stuff. So this is where, when the computer boots up and it starts presenting a virtual file system, or all file systems are virtual. So what I mean is, when it starts presenting the file system starts at the root. Oh, whoops, I'm not showing you. Let me get back to this. Sorry. There we go. So ls/ the file system starts at the root. So we've got all of the stuff here that's at the root. But then there's also home, and home is tilde/. So if we look at tilde/, that's where I have my there's stuff I need to move in a projects directory here. Desktop, documents, downloads, major screw ups. This is the file that I keep in my home directory for whenever I need to install something as root, or I need to make a system level configuration change. I always put it in my major screw ups file. I should probably give that a different name, because then every time I'm on stream, I feel like I need to describe why would I call a file major screw ups? Because is this like my intensely personal diary of all the wrong things I've done in my life, or what is the major screw ups? But no, it's when I screw up my system in a major way. If I have to run a command that requires sudo, I log it in here so that when it screws up the system, I can go back and see what I did. So when I had to install ffmpeg as a system library rather than as the user library, I put that stuff in there. Screen captures, sites, yeah. So this is, ideally this would only have 5 or 6 things in it, but that's my home directory. So things either start from root or they start from home. And if we look at pwd, so if I go into root and we do pwd, we see just root. And then if I go into home, well, I already am in home, and I do pwd, you can see that it's under users AJ. So using the tilde is the same as using users AJ. It's listing the same stuff. So I did ls tilde, it's that list. I did ls users AJ, it's that list. So it's a built-in shortcut that's part of the shell. The slash is actually part of the file system. The tilde is part of the shell. And then there is // or .. And in some shells, depending on the shell, the ZSH allows you to do triple / and quadruple /. But / refers to the current shell, because if I created a file that the name of the file is -rf, so now this file -rf exists. I can see it, it's there, but if I try to list it on its own, ls-rf, ls says, I don't know what you mean by -rf. I don't know what that means. But if you put the / in front of it, then it escapes it, so it knows that it's the name of a file. It's not a flag. And we'll get into flags later. The book is going to get there shortly, I presume. And then I can rm./rf without being worried that I'm actually going to delete my whole file system. So there's that bit there. Okay, we know what's really there. Yeah, referring to the major scripts directory. So let's see. Let me get back here. So to comments, the directory stack can hold up to, but this is, I don't know where you're getting this from, Jay, but that is going to be specific to a particular shell, right? So each shell is different, each terminal is different. You can configure how long the history is or how much it can hold. But yeah, the directory stack can hold up to 16, it looks like less than 16K. I'm guessing it's less than 16K because there's some basically padding characters or something that take up some amount of space. But almost 16K characters, about 500 entries. It just clears out the oldest entry once you fill it. Okay, that's cool. But that's going to be implementation specific. That's not a POSIX thing. Pushd is not part of POSIX. That's interactive shell stuff, not scripting shell stuff. Okay, so moving on. So current working directory, relative path names, we talked about that. You cannot change the path to a file. You can just change the path to a directory or a symlink to a directory. Let's see. Yeah, so he's just doing the same exercise that I just showed you. This makes sense. I mean, I'm being directed by what he's introducing, but I think he's doing a good job because he's introduced a concept, do the exercise to show that it works. Okay. Oh, and something that I totally forgot to mention, but file names that begin with a period are hidden. So back when I did, let me put my cup holder here and bring back the terminal window. So, and we can show this on both sides. So let me show the Finder one again. All right, so Finder's here. So this is our delete me directory. Let me get back into that. So I'm going to go into downloads, delete me. And I want you to watch what happens. So I'm going to do ls-A, or LA for short, because I made an alias for LA. That's an interactive thing. But you can see that there's this Apple file.ds store, there's a JavaScript file, there's foo, there's heyout. But if you look over here, whoa, double cursor, weird. So if you look over here, there is no .ds store. The .ds store is directory. The D stands, I think it's for directory. It's the directory settings, DS for directory settings, if I'm not mistaken, store. And so if I change, let's see, if I change the way that this is viewed, if we were to look at the date stamp, in fact, let's do that. ls dash, and I like to do laugh. Was it like this? Yeah, laugh. L, capital A, lowercase h, capital F. We can see when this was last changed. And I would be very surprised if that's not just a few seconds ago. It looks like it actually is more than a few seconds ago. Weird. Because when I change the way that I want to view the file system, like this, usually, but apparently not always, that will update the DS store. The DS store is what stores the settings for how it should be viewed. Let me see if doing those changes made any difference. Yeah, okay, so it updated the timestamp. So you can see now that because I changed the way that it views, it updates that file. Now, likewise, if I touch .bar, because of my settings for Finder, you can see it's kind of got a ghost outline to it. If we go back into Finder, let me see if I can go to Finder preferences. Okay, here we go. If I don't do, I have somewhere in here show all files or something like that. Let's do general, tags, sidebar, advanced, show all file name extensions, no. Show warning, no. Show. I don't know where I have it set, but somewhere I am using a setting that causes hidden folders to show up, or hidden files and folders to show up. Also, here's just something interesting if you're a Mac person. If you make a directory called blah.app, notice it created an invalid app that can't be opened. I could go in there, I could put a script in there, and I could set all the right things that this would have an icon, and that you'd be able to double click on it and it would run the script. In fact, I did this for my wife because she needs to connect to a VPN for work, and because of the VPN's not compatible with the Mac VPN settings in the system settings. So we installed a Cisco command line VPN tool, and then I did this with her so that she can double click on the app, and then it runs the terminal thing and then connects her to the VPN. So that's just a little side note there, not anything too important. Okay, let me check any comments here. You like to use dot on websites? So with websites, you got to be really careful when you're building your web applications, and this is really, really important to know when you're doing your development and you're on a dev machine that's not containerized, not in Docker, not in Kubernetes, not in anything like that, just a normal DigitalOcean VPS or something like that. If you are not careful about your URLs, you could actually let someone get to your passwords file by just doing // // so on and so forth, they would be able to get back to the root. Because if I do this locally, I actually need to group these items together. Let's see here, group. And let me go back to showing these. Okay. So if I were to ls ... that's the parent directory. It's one level up. That's my downloads folder. If I do ... again, that's the parent directory, which ends up being my home folder. If I do ... again, then that is the user's directory. And if I do ... again, that is the root directory. But if I do ... again, it's not an error. It's just the root directory. And I can keep on doing that over and over and over and over. And then you can also do any infinite number of dots as well. Now, web applications may or may not respect this, but if you do have a web application that is using file paths, you need to be sure that the double dot is excluded, or that the static file server has some sort of strict mode or safe mode that doesn't allow traversal to parents beyond where that static web server is mounted at. And I think that most of them do these days, but if you're implementing it yourself, if you're letting people upload pictures and then download pictures, for example, you need to make sure that you do not allow a slash to be the starting character or a double dot anywhere in a double dot with a slash or a slash with a double dot anywhere in your application. That should not be a valid input. Okay, and then back to the book here. So, and then this is the same stuff that he's saying. He's talking about CD. We didn't talk about CD hyphen, but CD hyphen is popd, but only one level deep. So you can CD to any directory, and then you can do CD hyphen, and it will go back by one. So if I do CD into temp, and then I do CD hyphen, it'll take me back one. So it's like popd. This I've never found to be useful. I would not teach about this other than to say it exists, but don't use it. The reason you don't use it is because pushd and popd are better when you need that functionality. And if you're in a POSIX shell, this is something that's really important, okay? So we're gonna do a little bit of POSIX scripting real quick. So let's go ahead, bring this back up, and I'm gonna create my hello.sh. It's a couple of things are really important. We need to start with shebang /bin/sh. This is critically important because this, whether you run this with bash or you run this with ksh or zsh, this will let it know to put it in POSIX mode. When it sees this, there are two special strings that tell it to put it in POSIX mode. One is user bin env sh. I don't really care for this one. Because it's just a little bit overkill. What this says is run whatever sh is in your environment. So if you were to create a link to a different sh than what your system sh is, it would run that sh instead, whereas this one is guaranteed to run your system sh. So you can go either way, but I think that this one's the better route because I don't know why you would have a user shell, POSIX shell that's different from your system POSIX shell. So if I run bash hello, it will actually run in POSIX mode, and we can demonstrate this. Don't pay attention to what I'm doing, but pay attention to this concept. So I'm going to do something that's a bashism. Okay, and I'm getting an error. My editor is letting me know, hey, you're in a POSIX shell. This is undefined. And if I run bash is going to be in POSIX mode. Oh, never mind. It still did it anyway without our erroring. Sometimes it will let you know that you're doing something that's not POSIX compliant, and it will issue a warning. I thought it was going to do that in this case. It didn't. That's okay. Anyway, so we start a POSIX script with this. This has to be the very first line. Pound bang or hash bang. Shebang is what it's called because it's your shell bang. Shebang. and then the path to the binary. So the path to the POSIX shell on this computer is bin sh, and it's linked to, I thought it was linked to something, but apparently it's not. This is, so I don't know what shell this is. Maybe, whoop, maybe we could find out. Maybe I could do sh-v. Interesting. Okay, so this, interesting. This is bash, as we can see here, but this is bash running in POSIX mode because it's called sh. So, weird thing. Anyway, so there's that. We also need to chmod a plus x hello. What this does, this we'd talk about in the permission section, but I think it's important to get it out of the way as soon as we write our first script. You want your script to be executable. So a plus x means all, meaning there's different permission sets. The a means all permission sets. So change the mode, chmod, ch change, mod is short for mode, change the mode of the file, all groups, all permission sets, plus x, meaning all permission sets get execute ability. So now we can run hello and it doesn't do anything, but we can run it. Whoops. It doesn't do anything, but we can run it. Whereas before, if I just touch a file and I call it, let's call this by.sh. Okay, I have not, it is not executable. So if we look at, if I do LA here, no, LL. Okay, we can see that by sh does not have any x's. And we can see that hello sh has a little star on it, which is often how it's denoted that it's executable. And then it has a bunch of x's. So for each permission set, it has an x. That means it's executable. So if I do by.sh, by.sh, I get a nice error because I'm in fish. If I was in another shell, then I'd get permission denied. Fish is a little bit nicer in what it tells you. Okay, so let's go back. The thing I was going to get to, though, is that in a script, in a POSIX script, when you want to change directory, you actually need to have a subshell, is what it's called. I don't know why I put it in. It's not fake quotes. It's just, this is the term. It's called a subshell. So, and I'll show you this. So let's do /ls. Let's see, what should we do? Let's do ls and then cd /temp ls. Okay? So what's going to happen here, and then we should do, we should always set strict mode. There we go. So now this is, what the reason it was complaining to me is if cd fails, it will continue on to the next line. The POSIX shell, for historical reasons, doesn't exit on errors. It just continues. And that could be really bad if, for example, you wanted to say, go into the temp folder and remove everything. If it fails to go into the temp folder, then it would just remove everything from the current directory where it is. So that's why that's really important. So we always want to do set-e, which puts it in strict mode, mean exit on error, and set-u, which means consider undefined variables in error. So what we have here is ls, it's going to list the current directory, it's going to change into the temp directory, it's going to ls the temp directory, and it's going to ls again. In fact, let's change this to downloads delete me. That's what this is going to do. So it's going to list a whole bunch of stuff. I'm going to have it sleep for 2 seconds. And you should be able to predict what this is going to do. It's going to list the current folder, which is my home folder. It's going to go into the delete me that we've been looking at, and it's going to list it. So we're going to see the same thing we're used to. It's going to sleep, and it's going to list it again. All right? So let's just go ahead and run that. So I can do sh hello.sh. Oh, it lists the current folder, and then we are in that current folder. Okay, let me go into a different folder, and then run that again. So that was in downloads, delete me, hello. Okay, so it listed the temp folder, and it listed the delete me folder, and it listed it again. In scripts, it's quite common. Whoops. Let me go back into that folder. Don't mind this. In scripts, it's quite common that you need to keep track of several layers of folder. You need to go down 2 folders, and you might need to go into a folder by a variable name and then come back. So you need the push D pop D functionality, but that's not available in POSIX scripting. So what you do instead is you do this. You create a subshell, and in the subshell you go into a folder. So subshell is just parentheses. In the subshell you go into a folder, and then you come back out of the folder. So we'll do this again. So I'm going to go into temp. I'm going to run hello. It prints temp. It prints the delete me folder, and then it prints temp again. So let me go back up and show that. So it printed temp. That was the directory I was in. It went into delete me. It printed what was in delete me. And then it printed again what was in the current folder, because everything that happens, what goes on in the subshell stays on in the subshell. Okay, shell quotes. No, shell quotes is something different. So it is important to note that this is not the same thing as this, which is not the same thing as this. We'll get into that later. But shell quotes are important. And the tilde does not operate. It is a special operator. Almost all of the shell operators work within quotes, within double quotes. Tilde is an operator that does not, or an expansion, excuse me, is an expansion that does not work in quotes at all. But we'll get to that later. Okay, let's see, is our video frozen up again? And the video is indeed frozen up again. So again, for whatever reason, I have to unplug and replug. I don't know if this is the fault of the capture software or if this is the fault of... I'll try to get this figured out for next time. Okay, there we go. So that's an important note about CD. Oh no. Yeah, there's the double quote, single quote, double quote, single quote. All right. So we learned how the shell treats a directory structure, yada, yada. Okay, now we're into exploring the file system. Oh, file and less and cat are all fun things. Yeah, that's pretty good. Let's see here. Now, if you're using an interactive shell, like I said, you want to use LSD. You don't want to use LS because LS is old and boring, and it doesn't default to having colors. It's not guaranteed to have colors. It doesn't work with nerd font. LS is not a good interactive command. It's an excellent scripting command because the POSIX behavior of LS is always the same. So where the spaces are, where the colons are, where the carets are, all of that can be counted on in order to... So if any system that has a POSIX LS, if you write a script that parses that information for whatever reason, it will work the same. But when you are doing, your day-to-day interactive shell, you want something like LSD. So this is just kind of going through all the stuff that we talked about. But he does bring up one really important point that is fundamental to learning shell, interactive shell, and shell scripting, which is the command options and arguments. And we can call them options, or there's also flags. I don't know if there's a strong distinction between those, but we'll get to that in just a second. Actually, we'll show... I like his table here. You can see this for LS. So this is fundamental stuff. I'm going to bring up the terminal again. So ls is a command, and since we're talking about quotes, and I actually have a video, I don't know if it's up yet, about whitespace. This is ridiculously important. So you can have any amount of whitespace between a command and an option or a, what is it called? Argument. Between an option and an argument. So flag, option, argument. These are the things we have. So command, and you'll notice here, if I type the command and it's not really a command, it's in red. That's because I'm using fish. As soon as the command is a real command, it goes blue. And that's because my color theme, it could go green or yellow or white or whatever. But I just use one of the standard color themes available with for iTerm and for fish that work together well. If we do, usually it's --help or -h. The command gives us what the options are. And then, oh, this one even mentions the separator. That's awesome. And then it gives us what we can do. So we can have any number of files. So we can do ls, some flags, some options, and I'll explain the difference between flags and options in just a second. The delimiter, and then any number of files. So we could have any flags, any options. We can only have one delimiter, I think. I don't know what would happen if you used two. I'll actually try that. I think it would just say file not found, and then file. I'm going to try that real quick. So the other thing that if we created a file that was called -rf and we wanted to list the file, we can't list -rf because it looks like it's flags, because flags begin with dash and options. But what we could do is ls --rf, and then that would list it. So we can use either the bit that's the part of, well, this is the way that the command parses it either way, because it's up to a command to parse the flags and the options. And that's not up to the shell. The shell will do this. So with the shell, if I give ls --rf, the shell is going to delete all of the extra white space. The shell is only going to pass ls --rf. And we can see this with echo. So I could do echo -rf, and it prints out rf. And I could do -r-f, and it prints out -r, and then hello, and then world. And then I can do bunch of spaces, bunch of spaces, bunch of spaces, bunch of spaces. So echo does not receive the spaces. Echo has no idea that the spaces are there. So this is one of the things that the shell does, not what the command does. The command only receives its own name, which is argument 0, and then whatever else comes next, which are arguments 1, 2, 3, 4, 5, 6, 7, so on and so forth, right? However long the arguments are. And so what I was going to show here is if we did ls --help, which in my case, you can see ls is actually lsd. Then there are flags. And the flags are typically Boolean. They're either on or they're off. So we have a flag for capital A is useful, which is almost all. And what that means is that it will list everything except for dot and dot dot, which that makes no sense to list. Because they are technically directory entries, but they're not useful to list because they're always there. Every directory has a dot, which is referring to itself, and also has a dot dot, which refers to its parent. And I'm not sure how much of that is at the file system level and how much of that is at... No, it's not at the file system level. It's at the level of the shell. Okay. And then there's some other options, display directory only, flags. And then there's options. So an option is where flags are typically true or false. And they're often used in their abbreviated form. And you can combine them together. So you can combine the dash... we can have the lowercase l flag, which is displayed as a table, with the capital A, which is show even the hidden files, with a capital, with a lowercase h, which is show it in megabytes or kilobytes or gigabytes rather than always in bytes, so that you don't have to do the math in your head or say, oh, that looks like 1 billion bytes. Is that 1 billion bytes? How many decimal places are there? And then F, which is classify F means that if it's a link, it has this arrow. If it's executable, it has a star. If it's a directory, it has a slash. It has a pipe if it's a pipe. So that's what I like to do by default. So I think that my ls does that. Yeah. So my ls is aliased already to LSD-LAHF. Well, sorry, AHF. And my LL is aliased as LSD-LAHF. So you can see the output's the same there. But the point of this is just to show that we have these flags, they can be combined together, and then options require something else. So if I want to specify color, what kind of color? Do I want the color to be always or auto or never? Auto means that, like I showed you before, if we put it to a file, so if I do ls and I put this into a file, when I open the file to read it, there's no color information there. But if I were to do, let's see, color equals always, then when we open up this file, there's color there. And if we were to open up the file raw, then we see all of these control characters. Caret, bracket, 38, colon, M, bracket. And these are the control characters that are defining what the colors are. So the automatic thing to do is to have it detects whether the output is the terminal that you are viewing or whether the output is a file. If the output is the terminal, then it will put the colors out. But if the output is a file, it will not put the colors out. And that's kind of an important thing to know. Yeah, Python, I think double quotes obey expansion, but single quotes are literal. And then isn't it R will allow you to put bytes? If you do R quote, then that's not just a string, but it's bytes. And if you do U quote, then it is UTF-8 or Unicode. Yeah, the POSIX shell is not that fancy in that regard. Okay, so next thing then, what I was going to bring up with this, so let's go back to those flags and options. So the options are that they're distinct from flags in that they require something else. And options often don't have a shorthand. So you can see all the flags. You can do either one of these. You can do -- almost all, or you can do -A. And with flags, you can combine the flags together if it's a single letter, but if it's a double dash, you can't combine the words together. So you can't do -- almost all -- classify. So I will do that as an example just to show you. So -- almost all. So let me do this with LSD directly. And then classify. But we can't put them together without a space. They require a space. And we can't put them together like this, right? But we can do A and F, and we can also do A, F. That is a command thing. That it is the POSIX standard. This is a behavior that is POSIX standard. So if a command follows the POSIX standard, it will do this. That is irrespective of the shell. The shell does not know dash or double dash. All the shell knows is there's some stuff, there's some white space, and there's some stuff, and when you hit enter, that's the end of the line, and it should run whatever was up to the point that you hit enter. That's all that the shell knows. All right, so almost last thing here. And then the arguments are whatever comes after. So the POSIX standard, and this is the way that Mac is, it's not the way that Linux is. Linux commands are generally implemented so that they can understand things in any order. But the POSIX standard is that first should come your flags, and the flags can go together. Then should come your options, such as, what was that one? Color, auto. And then these two, I think, are supposed to be the same. I think it's supposed to be that you're allowed to either have a space or have an equals. but that's implemented at the command level, and I don't know for sure which the POSIX standard is. This is what's more common, but you will see this sometimes. Anyway, so flags, then options, and then arguments. So in this case, I could give it the argument of temp, and I could also give it the argument of downloads delete me. So I can have ls accepts any number of files. And then you can see it's listed like this. Now, a cute little thing, if I do pipe, which is that I'm going to take this output here and I'm going to use it as a file for the next program to read from. So there's a command called grep, and it will, I'm going to search for anything that matches the letter A. So grep is putting the red here. The color did not come from LSD. And LSD's behavior changed because, and let me see what would happen if I changed this to always. Okay, so now we have a mix of color from LSD and color from grep. Because the program is given information, the command is given information about whether it's writing to a file or to a terminal. And when you use pipe, or when you use the director, it knows that it is to a file. In the case of pipe, the file is ethereal. It's a temporary file. And the next program is told to read from it. Yes, thank you for that. The slash, okay, so everybody can see here, this was the comment. Yeah, the, right there, that one. Yeah, that, it means something. We can use it. But so this, it knows whether it's writing to a file or whether it's writing to a terminal. When you do the director to a file or the pipe to another program, it knows that it should treat it as a file, and it will not do the things that it will do for an interactive shell. So this is the difference. Many commands, when you run them in interactive mode, will give you different output. So here, I'll just say, I'll use bat again, actually. So what this is going to do is it's going to exactly put out to the screen what it receives. Okay? So in interactive mode, LSD produces output that looks like, oh, whoops. How long have I been doing that without showing what was on the screen? Hopefully not long. So in interactive mode, ls will put everything out to the screen pretty printed like this. But in file mode, in script mode or batch mode, it puts things out to the file like this. So notice the difference between the two. There's no color. The line spacing is different. And so for me, a lot of times when I instead of specifying all the options, like for example, if I wanted to do this, put this in file mode, I could do, color equals never, I could do something like that. But what I do, if I want to put something in file mode to be able to see what it would go to a file, I'll just do pipe bat, just like that. And then that will give you, it would be cat if you are using a POSIX environment. Bat is an improvement upon cat. Cat stands for concatenate, and bat is cat with wings. So it's just a better concatenate program, but it just writes out whatever you give it, it writes out, whether it's a file or whatever. Bat will do colors and stuff like that, whereas cat generally does not. And bat is available at webinstall.dev/bat. So anyway, that's what I do. So I think that's kind of off the beaten path. I don't think he introduces that concept until much later, but I think it's actually one of the core concepts that should be introduced early on. Okay, so let's keep going. And I think that it is good to learn the options of these commands individually, but I am focusing more first on learning about the differences between the shell and commands in general, and then learn about the specifics of the different commands. And I think for each command, there's basically one or two ways that I use every command. There are hundreds of options. Oh, let me get back to showing this on the screen again. And of course I have to redo it because it crapped itself again. I am so confused as to why that's happening. I don't know if it's because of the phone is having a problem or what it is, but it's happening. So, and then of course it got dark again. A cloud came overhead, so now it's darker. So I will go ahead and tap to make this brighter again. Boop. Let's do ISO and... Oh no, that's focus. No, focus is good. Keep the focus. It's exposure that's bad. ISO. Give me ISO. There we go. Okay. Good enough. All right. Now, what was I saying? Yeah, there's a million options for every command, but what I find is that generally when I use a command, I only use it one or two ways. And so I don't recommend overloading yourself with learning all of the options for a command. I can tell you for ls, there's only basically three ways that people use it. And so what you'll find is that people make aliases for ls. There's one that's ll. So these are not the commands, but they're an alias to the command. So there's ls. I just like to turn on the classification. I like to have the colorization, and I like to have the almost all for me. Well, that actually LA is almost all. So LS is typically just default options, but maybe with color and stuff like that. Then LA is the same as LS-A. And then there's LD, which is typically the same as LS-D. Is typically whoops, sorry, I was wrong about that. That's not LD. I don't remember how that's often specified. Maybe, but I guess I just use LL, LA. I thought there was one other. LT, was it LT? I don't remember. But yeah, LS is the command, and then people will write aliases that are LL or LA or whatever. And aliases, I can go ahead and show you what that looks like. They're pretty much the same for every shell. So I'm using fish, but it's kind of the same. So for me, it's this is very, very simple. Whoop, let me actually bring that back up so I'm showing you again. Sorry, I keep on forgetting to show you. I totally wasn't showing that whole... This is what I was showing when I was talking about LS versus... so there's LS-A, LS, LA. That's what I was talking about right there. And then if we go into the config, so here are my aliases. And they just go in my config file and they load when this loads. And this is true for fish, for ZSH, and for bash. Your interactive shell will have aliases. So I have LS, LL, LA, and then I have tree. These are my aliases for LS. And one of them is with -F. One of them is... It's kind of weird that I put it that way, but I think I actually understand why I did, so that F would always come first in all of these. Because normally the way that I think about it is laugh, and then FA. And these are the same whether it's LS or LSD. The options, the flags and options are the same between the two. Because LSD is just it's like LS++, and BAT is cat++. And the same thing with a lot of these newer commands that they're not POSIX commands. Curly is curl++. I don't know why I commented that out. I'm going to uncomment that so that that's working for me again. And then tree. Tree is LSD-F-tree. So these aliases, you could copy. In fact, I'll just send them to you real quick. No number. You could use these in your bash RC, in your ZSH RC, in your fish config. All right, go grab your drink. I can't get this to go through correctly in chat, but I'll just paste one or two then. I don't want to try to paste them all. So there's that. And there's this. And there's LSD. So again, interactive scripting. So, and it would be the same whether you do .profile, which is what your POSIX shell is .profile, .bashrc. If you're, I don't know, there's no reason to use bash as an interactive shell. I'd highly not recommend that. That seems like a very unwise choice. Bash, I would not recommend bash for scripting or for interactive because it's not good at either. It's kind of, it has become the worst shell to use for any reason. Because we need POSIX for Docker and web dev, and then for our interactive, we need something like Fish or at least ZSH. But here's your, no, ZSH is, I mentioned ZSH. I don't recommend using ZSH. I recommend using Fish. Because ZSH is trying too hard to be bash. And it's not written very well. It's trying to rely on the old libraries, the way that things were done in the 80s. And it's an incremental improvement over the way things were done in the 80s. It's not an extraordinary improvement. Whereas Fish is very modern. As you can see, if I type something, it fills it out in gray. Let me see if I can do, there we go. So let me, nope, that's not what I want. This, here we go. So the last time I used Fish, last time I used Find, this was the command I ran, right? And you can see the whole thing's there. And if I just hit up, it goes through, these are the last commands that I ran. I can just hit up or down. That's interactive shell for you, right? ZSH just is not up to speed. ZSH is stuck in the 80s. ZSH is taking what was done in the 70s and 80s and improving upon it slightly. Whereas Fish is kind of reimagining, what if we just used all the technology we had in the 90s and just maxed it out today? Okay, so, oh, and of course, what is going on with this connection? I will have to find out what is going on with this. This is just too annoying to have to turn this thing off and on, off and on, off and on, off and on, and reselect it every time. But let's get back to the book, and I've only got a little bit more, and then it will be time for me to go. But let's try to finish up this chapter. I know I'm taking so long explaining everything, and we're mostly talking about interactive stuff. It's when we get to the control logic, the ifs and the while loops and that kind of thing, that's where we're really going to be talking about POSIX, as opposed to interactive. So it recommends less, and less is fine, but bat is better. So bat replaces both less and cat for interactive shells. There's no need for something like less in a scripted shell because less can't do anything. There is sometimes a need for cat in a POSIX shell script. And then, yeah. So he makes the point here of what is text. And I think that is actually something really fundamental that you need to learn early on. A lot of people get hung up on this. Text is anything that you can type on a phone in a text message. That's what text is in opposition to, say, binary. And we'll print this out to the screen shortly, and there's actually a command reset that will reset the terminal that comes in handy here. Let me answer a couple comments. What are your OBS settings for the phone video source? My OBS settings are, it is preset high. We could probably take that down a notch to not high. Nope, doesn't like it. Now it's freaking out. That broke it. So it's just use preset. Preset is high. I think that it's the phone is crapping out. Yeah, 54 variations of poop emojis are considered text. Oh, good. This is working again. Okay. I don't think it's the OBS that's the problem. I think that it's an iPhone 6 that's cracked. So I got it for free. And I thought, yay, free camera, woo! But now I'm thinking maybe it's not woo free camera. Anyway, so let's catch up on the comments. Do you have to deactivate when not showing on? No, I don't. But I think it has to do with the camera and the software. I think that something's getting corrupted there. I don't think it's on the OBS side, although it could be. Yeah, you can see it now, but it's just, what will happen is it will freeze. And then you won't see movement and you won't see what I'm actually doing. All right, so I wanted to show text again. So I'm not actually unshowing. If you look closely, you'll notice that down here in this layer, whoops, right there, you can kind of see where my arm is. You can see now I'm moving my hand across. So you can see underneath the terminal that the video is still on, but the video will freeze sometimes. Do I have no, the phone's set up correctly. There's no screen lock. There's no time lock. All I'm doing is unplugging the USB cable, replugging it, and then resetting the OBS source by switching to something else and then switching back to the phone. Yeah, text encoding. So there is an excellent talk that I would recommend. I think it's on Creeds of Craftsmanship. Yeah, it is. So I'm gonna direct you to creedsofcraftsmanship.com and I'll tell you the title of it in just a second. If you want to learn all about text encoding, the talk, I think it's called Pike Matchbox. Here it is. So that's a place to learn about text encoding, but just to kind of see, so Cat will print out a file as text. It will print out any file as text. So it'll print out hello, and there's no color or anything. Now, if I use BAT, which is for interactive shells, then I get the color and all that, right? So that's the difference between Cat and BAT. Now, if I go to print out, say, bin sh, here's a doozy. So this is the difference between text and binary. Binary often has text inside of it, so you can see that sh has some sort of tag, probably just letting you know that it was compiled. Oh, this is the certificate. Okay. Sign. Okay, so Apple has a header on this file that lets you know that it's a signed program. That's why when I run sh, it doesn't pop up and say, sh is a program from an unidentified developer. Are you sure you'd like to run sh? Because Apple has signed this binary with their certificate to say, look at basically the rest of this file, hash it together, and this is the Apple file. It actually looks like a couple of things are going on here. Interesting. Very interesting. Oh, okay. That's at the end of the file is the Apple signature. Got it. So the Apple signature is actually at the end of the file, not the start of the file. The start of the file, it has these debugger symbols in it from when it was compiled from C code. It has linker information in it about where it's supposed to find the system libraries. That's really interesting. But this is binary code here. It's got a lot of Apple signing certificates in it. Interesting. It's got something about Dash in here. That's really interesting. I don't know what else is going on there. That's kind of weird. Let's take a look at Bash instead. There we go. Good old Bash. So I think that the SH program on Apple may actually be... Oh, look, here's help. So you can see that the text help is embedded in the Bash program. So all of these strings... How many strings are there? That's quite a few. All of these text strings are embedded in the program. So when you get the help, this is where it gets the help from. The help is obviously baked into the program. But you can see it all right here. Look, here are the error messages. All the error messages are in there. But the things that get all wonky-do, and all the question marks. The question mark is the Unicode replacement character for saying, I don't know what the heck this is. So plain text is 128 possibilities from 0 to 127. And Unicode allows you to join multiple of those together to get emojis and stuff like that. And you cannot copy and paste this into a file and create a program. I could do this. I could do cat, and I could do bash, and then this bash will be a program. What? Not executable by this user. Oh, whoops. Let me do bash here. There we go. Oh no. So it didn't like something about that. Maybe it didn't work because it tried to copy it in text mode. So let's try something else. I'm going to try bin bash bash. Nope. So bash just does not like being run. The way that it was compiled, it does not like being run from this directory. Yeah, we just kill it. Get rid of it. All right, great. Anyway, so when you look at things like HTML and whatnot, well, even if we look at, say, let me go ahead and run ls again with color equals always. So there's some control characters here, and those are not plain text. So if I were to look at this with something like hexel, let me Webby hexel, get the latest version here. There we go, hexel. I spelled it wrong, that was all. So we can take a look at what it can see, and it shows us here's what it looks like in hexadecimal, and then here's what it looks like either as text or whatever it can interpret it as. There we go. That's a fun one. So Hexel is a really good program, and again, you can get it from webinstall.dev/hexel. That's a really good program to be able to see the difference between binary in a file and the text in a file and what it looks like in the different you can see how it's encoded this way. Woo. So I think all of the green dots are space characters, all of the X's are control characters, all of the black dots are nulls. So it has a nice way to kind of display it to you, and then you can see, okay, what type of space character or control character is it? I guess that's actually green, not yellow. It's kind of hard to tell right now. Yeah, if you want to be in the 80s, you can use XXD. So bin, bash. Yeah. Yeah, so, yeah, there you go. Yeah. So Hexel is just, and I think XXD might actually be part of the POSIX spec. Oh yeah, strings. That's a good one too. So strings this will work for C programs. It can tell you what things are denoted as a string in a C program. So if a program was written in C, or it was built with a C compiler that uses, and the programming language uses the same type of string syntax as C does, then it can print out all of the strings. Yep. So that's difference between text and... no, I do not want to try running strings on a jar because it's zipped. You have to unzip it first. You need to rename it to .jar.gz or jar.zip. I don't remember which. You need to unzip it. Then you could do that. Okay. But yeah, so I think that the more important thing is actually when you're thinking about things like a Word document, because a Word document is not text. A Word document is zipped XML. So let me see if I can find a .doc real quick. .docx. Seriously? No .docx in my downloads folder? Okay, cool. There was some resume writing one docx. There we go. So check this out. What we're going to do is we're going to copy this file, because this serves as a great example for the difference between text and binary. So we know kind of what this looks like. I'm going to go ahead and open it up in the preview. Actually, I'm not, because it wants to open up pages, and then I need to redo my screen. But you can imagine this is like a simple template for something. I don't remember what it is. I think it's for a writing class. It's called Writing 1. I think it's the first assignment for a writing class. We can just rename this to Writing 1. Most files that you use with different programs, whether they're Adobe programs or Microsoft programs or Apple programs, most of them are just zip files. So if we rename this to .zip, and then we use unzip Writing 1, see, you can see that it just unzips it. So almost all application files are either zip files or GZ files. And so then inside of here, there's Word, and then inside of here, let's see, is it doc props, rels, content types, Word, document. So I can open up the document. Let's see if I can have this pretty print. Give it a second. Does it want a pretty print? No. Ah, there we go. A very good way. See this right here? So this Word document has text in it, but then just like we had those control codes with the colors and stuff, this has a bunch of XML style controls that tell it, what color is this supposed to be? Is it supposed to be underlined? So this W here, there is a capital W. So you can see hitch your paper. So before that, there's going to be a W somewhere. Oh, interesting. So this might have had comments in it, or it might have to do with the spacing in the document. So this is a text file in the sense that we can see the text, but it's not a text file in the sense that when you open a Word document and you see text, the text is actually encoded in a document.xml that's inside of a zip file. And so when we say a text file and we're talking about scripts and the terminal, we're talking about files that are plain text that can be manipulated easily with command line tools without having a large application. Now, in some cases, like with Word, if you know what it is, you can unzip it, you can go edit the file, you can rezip it, and then you can open it in Word, and Word will be none the wiser. Let's see. All right. And I gotta put the camera back on, and then we're about to wrap up for this session. This totally went in different directions than I thought it would, which is totally fine. But I was thinking I was just going to read from the book, but we had a lot of conversation and questions, and that's absolutely awesome. Was this not a docx? It was a docx. Hold on, let me bring that back up real quick. See, this is a docx. Look, writing1.docx, and then I renamed it to docx.zip, and then I unzipped it. This is a docx. I haven't heard of Binwalk. I don't know what that one is. Okay, so we've kind of talked about a text file versus binary. The binary basically just has commands for the computer. And what else are we going to talk about? So this is actually more about Vim than it is about less, but and bat works the same way. So you'll find that the Vim commands or VI commands, the POSIX VI commands work in a lot of applications. So things like up and down, G, capital G, lowercase gg, slash, all of these things are actually Vim commands, but they also work in a lot of other programs. They'll work in bat, they'll work in less, they will work in more potentially. Oh, and it talks about less is more here. So there's three programs that are the same thing as what less is. The newest one is called bat, which also does what cat does. Bat, but more and less are considered pagers. More is, was it less? I don't actually remember which one is the newer one that's the POSIX standard. I'd have to look that up real quick. But, well, you don't use them anyway in POSIX because you don't use them in scripting. Let's see. Remembering the copy and paste trick. Oh, this is another thing for interactive shells that's really important to remember. So in an interactive shell, all you have to do is select something and it's copied. And this is true pretty much across the board. So if I take this and I select it, or let's say I take this one and I select it, then I can go paste it in the chat, and I didn't press anything. So I'm just pasting it in the chat. So that's an interesting note. And again, we'll actually get more into the real POSIX stuff when we get to the scripting aspect, because that's where that's going to have the biggest effect. Okay, so also, let me, it's getting warm in here. I have 3 heaters running right, well, 4 heaters actually. I have 4 heaters running right now. They're all on low, and 2 of them are off. I think 3 of them are off. Why do you have so many heaters, AJ? Because it heats the room quickly, and then they don't consume very much energy because they're each rotating in turn. I don't. Okay, and then this is Linux specific stuff. I don't think that this is actually really that important when it comes to either interactive or scripting, so I'm going to skip it. I guess knowing what these directories are, I would put this towards the back of the book because it's just not important for scripting. Bin, boot, dev, they're all standard directories. There's a bunch of standard directories. They're kind of organized according to a very logical system of is it writable? Is it writable by the user? And do the files change often? It's based around permissions and disks. So if you think about the olden days when you had multiple disks to run a system, one disk was your boot disk, and another disk was your user storage disk, and another disk was your temporary file disk. And the temporary file disk needed to be faster, and it was going to need to be replaced sooner because so much stuff was written to it, and that was going to break it. So the way that the directory structure is organized, also memory was much more scarce, and so you had to load programs. You had to be really conservative about how you loaded a program into memory. So a lot of the directory structure stuff here, if we were to redo this today on a modern operating system, if we were to build an operating system from scratch, I don't think that we would do it this way at all. I don't think that this is actually relevant to modern applications. It is relevant in the sense that when you do a web application, you'll often have a bin directory where you put your scripts. You'll often have maybe an etc directory where you put your config. You might have a lib directory where you put your code and asset files. I don't know. I don't think this is really relevant to today's world. Oh, and of course you can't see because I've still got the terminal up. Oops. All right. And then, so symbolic links, this is really important. So a symbolic link is basically a shortcut. Let's see, how much do we have left of this chapter? Oh, we're almost done with the chapter. So we got through 3 chapters. I think we'll get through more next time because I won't spend so much time. A lot of the tangents that we've gone through are basic stuff that is really important to learn early on. I'm going to be, what I'm excited for is when we get to the part about the actual scripting. That's where I'm really interested. But symbolic links, hard links aren't even used, but hard links is when you have the same name in multiple directories that is the same file. It is the same file. You list the same file in multiple directories, not a copy of the same file, the same file. So there's one copy of the file and it's listed in multiple directories. Generally, you make copies of a file, but in newer file systems like ZFS and the Apple file system and ButterFS and all of these, when you make a copy of a file, it actually is a hard link, but the hard link, rather than being managed up at the file system interface layer with the operating system, the hard link is managed in the database of the file system. So if 2 files are identical, the file system simply does the hard linking automatically, what this makes difficult is that on modern file systems, it's hard to tell when the disk is full. Because if you were to list all of the files and you have, say, 10 copies of a 10 gig video file, it will get listed and counted 10 times, 100 gigs, but it will actually only take up 10 gigs of space. But the symbolic links, is just a file that is a pointer to another file. So it's very much the same as a shortcut or an alias. In fact, I think the reason that on Windows and Mac shortcuts and aliases are different is that links do not contain any metadata. So when I say, for example, I link from bar.js to baz.js, and the link it doesn't work the way that you think. The link is relative to the target. So, and I'll give an example of this in just a second. So I don't think I put anything in bar.js, but let's go ahead and put in hello world. That's totally wrong, but we could maybe call it bar.txt. So if I were to put this out to the screen, and if I were to put out Baz to the screen, the one is a link to the other. If we look at them, we can see here, Baz is a link to bar, and bar is not a link, because you can have a link to a link, that's fine. But there's no metadata associated with this. If we look at it, and let's go ahead and bring up the Finder again. Let's see. Finder. Where's our Baz? There's Baz. Oh, we can't see it over there. There we are. Okay. So here's Baz. And it's interesting. Oh, it's detecting it. It's not using it is using the file system. So it's saying it's a .js file. Okay, let's do something different. I'm going to move bar to bar.txt, and I'm going to move Baz to baz.txt. Now the link is going to be broken, and you can see this because now Baz, whoops, let's get rid of that. Baz is still a link. I renamed Baz, but Baz is still a link, but the link is pointing to bar.js. The only information that this link contains is, and this is at the file system level, it's not a file with stuff in it. It is an entry on the file system. It contains the information of bar.js. That's it. That's all the information it contains. So if we move it to a different directory, let's say that let's go ahead and get rid of that. And we'll do ln-s again, and we'll do, we're going to link from bar.txt, and the link we're creating is bar.txt. So now this link is good again. So we got bar.txt, and we have, where's Baz? Whoops. Oh, whoops. I did that. The link we're creating is baz.txt. Sorry, I didn't recognize that error that was right there. So what's happening is that we now have a Baz and a bar, and if we bat them out, we see they're the same thing. But check this out. If I move Baz, which is the link, if I move it to temp, and then I try to bat out baz.txt, the link is relative. The link doesn't follow that file no matter where it goes. The link is relative. So the link just says, the only information I have is I point to bar.txt. Where? Whatever the current directory is. So you move the link is broken. You move the link back, the link works again. And the link, so I can go to temp here, and I can get rid of this link that we created. I could, what was the other file we created in temp? We created an ls.txt. So I could do this. I could do ln-s, and we're going to call this, we're going to say it links to the information we're putting in the link is ls.txt. That's the information we're putting in the link. There is no file in the current directory ls.txt, but we're going to make the link in /temp, and we're going to call this bar.txt. Now in temp, there is an ls.txt. This is really important because it's easy to get hung up on. The link is what data are you going to write and what link are you going to write that data in. That's how the ln command works. The data that you're going to write and what link file you're going to write it into. So when we look at this now, it works. Even though if we looked at it relatively, and we could even do this. We could do // and then we could put this in baz.txt. But the / is not relative to where I currently am when you're creating a link, because the first item that you're dealing with is the data of the link. So wherever the link is, that's what this applies to, because the link is in /temp. The data that the link contains applies to where the link is. So that's something that's got me hung up in the past a few times. So let's see. Let's just go ahead and print all these out again one more time. So yeah, that's the good thing to know about links, I think. And then we are over 2 hours. So I am going to go ahead and cut this off, and we'll spend another 2 hours sometime this week, and we'll go through more of this. So if you're interested in that, go ahead and like, sub, follow. We're going to go through at least this whole book. And I'm going to be using these sessions, especially the questions you ask, the things that come up. I'm kind of making note of these. I'm making note of these so that as I'm producing the material on I think what I'm going to call this is functional shell scripting for the modern age. POSIX, Bash, Fish, etc. But I'm making note of the kind of questions that get asked, what the material is, what's kind of coming through my mind, because unfortunately, I'm not a linear thinker. I have to go through some material to kind of experience, and I jump around, but I'm doing this so that I can be able to consolidate this into a mini course on modern shells and functional scripting in POSIX, and then modern interactive shells, and kind of create that separation between the interaction and the scripting. Anyway, thanks for joining in. Really appreciate it. Again, remember, like, sub, follow if you want to. If you like what you like, you get more of what you like. If you follow, in the past, this channel has been a lot more of me doing work. It is transitioning back to what it was not last year, but the year before, when I was doing more stuff like this, study sessions, doing small projects on the stream. So I am occasionally going to do work on the stream, but that's not primarily what I'm going to do. That wasn't my intent. It kind of accidentally fell into doing work all the time because my life situation changed and I got a house and I needed more money. And so I was working after hours. Now I've readjusted my job situation so that my working hours provide me the money that I need, and I have after hours to work on experimental stuff like this. So this Cool Age 86, both on Twitch and on YouTube, is going back to that style of content that I started it with the idea of doing. And the work content is splitting off into other channels. So if you want to watch me doing my day-to-day work stuff with Dash or one of my other clients, then the Dash stuff is on Dash Incubator, and the stuff with the other clients, I may release a channel for that later on. Just kind of a Cool Age 86 MISC or Cool Age 86 long hours. I don't know what I'll call it, but there will be another channel for when I'm slogging through work stuff if you just want to join in on the stream there. So with all that said, again, thank you very much for joining in. I hope to see you again. We'll do this later this week. I'll try to join the Discord. There's the link right there. So join the Discord if you want to be in on that. I try to only at everyone once a week or less. And I do at here when I'm doing a stream that I feel has got more value to it. So feel free to join in on those things, and I will post that link one more time for anybody that does want to join in. There's the Discord link one more time. And with that all said, thanks very much for joining in. We'll resume next time at Chapter 4. Could be, well, I'm not sure what day it'll be, but I will announce it on Twitter and on the Discord. So thank you very much. Oh, wait, we need to raid. I'm sorry. Where are my manners? Okay, we're going to raid. Let's see, who have we got here? We got RWX Rob is, he's just chatting right now. Okay. And we've got CM Griffing. We're going to go to CM Griffing. He's working on a food app of some sort. So let me, whoops. Oh, it was saying, why is it saying what audio input it is? Go back. There we go. That's where we're going to raid. All right. So join in if you want to do that. I am out. That's starting in 5, 4, 3, 2. Well, actually 8 seconds, but all the same. Adios.